Hi everyone, this is Russell Matheson. I'm here with a video just detailing how your derivative rules you might have learned in class you can use together to solve these really big derivatives that may seem hard, but when you break it down to their components, they're actually not that bad. Alright, so first off, let's go over the derivative rules that you should know from your class. So you have quotient rule, product rule, and chain rule. Now the first rule you're going to always use when you have any function like this would be quotient rule. If you see a fraction, go ahead and do quotient rule. So you're going to have the derivative of f of x over g of x, and that would be equal to all that right there, g of x, f prime of x minus f of x, g prime of x, all over gx squared. All right, so first step should always be, if you have a fraction, get it into a quotient rule. You get just general looking, as general as you can. Then you can use product rule and chain rule. So product rule, you're going to have derivative of f of x, g of x, which will all equal f of x, g prime of x, plus f prime of x, g of x. All right. Then lastly, you're going to have chain rule, which would be you have two functions, one's inside the other. You do the derivative of the outside function first, keep the inside function the same, then do the derivative of the inside function. Okay. So I know that seems very general and everything, but we're about to do an example that'll just show us how all these rules come together to create your end derivative. All right, so here we go with the example problem. So we have find the derivative of cosine x to the third e to the 7x all over 4x to the fourth. All right, so like I said before, with our quotient rule, we have f of x over g of x, and we want to get into this form, and that's our first step into looking how to solve this derivative. All right, so I've already done that here. So we have, I factored out that 1/4 you have 1 over 4 sitting right here. All right, then you have the derivative of the whole thing, cosine x to the third e to the 7x, times the original function, x to the fourth, minus the derivative of x to the fourth, and keeping the top function the same, cosine x to the third e to the 7x. And then you have x to the fourth all squared under here. All right? Now we have the same function up here, and now we have this whole thing right here, the derivative of cosine x to the third e to the 7x. So, as you may see, these are two different functions, and we're going to use product rule. So you have derivative of cosine x to the third times regular e to the 7x, then the derivative of e to the 7x, cosine x to the third. And these are both chain rule problems. So you're going to apply the chain rule to each equation. So you're going to do the derivative of the cosine, which is negative sine x to the third, and then the derivative of the inside function x to the third, which would be your 3x squared right there. And the negative comes with the sign. All right. Same thing for e to the 7x. The derivative of e to the anything is e to that multiplied by the derivative of the top, which would be 7 in this case. All right. So remember, this was originally let me go back. A product rule question. So we need to get those chain rules back to looking like the product rule. So you're going to have in this form negative 3 to the e to the 7x, x squared, sine x to the third, plus 7e to the 7x, cosine x to the third. All right? So lastly, now we're going back to the quotient rule part of this, and we're plugging in everything we just got into what looks like the quotient rule form. So we're going to have 1/4, all of that product rule and chain rule stuff, times x to the fourth, minus 4x to the third, which would be the derivative of x to the fourth, keeping top function the same, cosine x to the third, e to the 7x. All right, that's all good right there. And so this is a completely valid answer, but this on the bottom is just doing some simple algebra and getting it into the simplest form we can, which would be e to the 7x times x times negative 3x squared sine x cubed plus 7 cosine x to the third minus 4 cosine x to the third all over 4x to the fifth. And that's your derivative. All right, thank you guys, and I'll be back with tips.